What is the maze-solving robo-rat? The maze-solving robo-rat is a Bluetooth-controlled robot that, through the use of an overhead camera, is able to solve a maze that can be modified to change the exit path as desired.
Our group wanted to create something that played into an increasingly automated society. With how much technology is advancing and society becoming more and more robotic, it seemed only fitting that we would design something that pertains to that. The Robo-Rat was our way of applying our knowledge of coding and hardware into the real world, so that we could better understand automated processes and how they work. The goal of the project was to create a system that would utilize a camera to take a picture of a customizable maze that would then be sent to the computer system. This system would use image processing and color recognition to detect the walls of the maze and determine the directions the robot would need to take to solve the maze. These directions would then be sent to the robot's computer, causing the robot to move through the maze in a relatively short amount of time.
For our design, we decided to go with 3 subsystems: a vision subsystem, a planing subsystem, and a motion subsystem, the components of which and their interactions can be seen in the block diagram. The vision subsystem consists of the maze, the lighting, the camera, and image processing software. The maze is a 3x3 modular grid. The lighting system is 4 diffused LED bar lights arranged in a rectangular orientation on adjustable mounts. The camera is a USB webcam, also on an adjustable mount in the center of the lighting system. And the software uses the camera to take a snapshot of the current maze iteration, and then uses the OpenCV library and HSV thresholding to isolate the colors of interest. For this project, we decided to use blue for the columns, red for the walls, yellow for the destination, and green for the robot. The rest of the maze is a flat white to avoid any excess noise in the color masking. The planing subsystem is an entirely software-based subsystem that uses the image processing data picked up by the vision subsystem to run a recursive algorithm on the current maze iteration and determine the shortest path from the robot to the cheese. This path is then transferred to the Raspberry Pi using a Bluetooth connection in the Pi serial library.
The motion subsystem was built using parts bought primarily from Adafruit. These parts include a 3-tiered chassis to serve as the body, a ball bearing to allow the robot to spin, and wheels attached to 2 DC motors that would be powered by the Adafruit motor hat. The robot utilized a Raspberry Pi 3 to program the motor hat using Python, telling each of the motors which way to spin and how much throttle to use. The robot was able to rotate when the wheels were powered to spin in opposite directions while being supported by the ball bearing.
For this design, the Adafruit B&O055 was used to provide real-time acceleration data from the robot to provide live tracking of the robot's location. This IMU has 9 degrees of freedom, 3 internal sensors, those being a gyroscope, accelerometer, and a geomagnetic sensor, and 7 measurable outputs, though only linear acceleration and angular rate were used for navigation. Our initial goals when beginning this project were 1. The vision and pathing algorithms complete in 15 seconds, and 2. The robot traverses the maze in a maximum of 180 seconds. After testing, it was found that the algorithms were able to be completed in an average of 10 seconds, and the average maze section, of which there are 9, took approximately 10 seconds apiece, meaning that the longest possible maze would only take 90 seconds to complete. This showed that both of our initial design goals were exceeded.
The computer imaging system is able to consistently identify the walls of the maze and determine the best path for the robot to take. It is also able to consistently make the robot start to move in the direction it must go. However, a problem that we have encountered is the system having a tendency to overcorrect the robot's position in the maze if it is slightly off from where it is supposed to be at a given time. This can lead to the system not realizing the robot's exact position and can cause it to move in the wrong direction, or it can start skimming the walls as it moves.
What is the maze-solving robo-rat? The maze-solving robo-rat
When I did 20.